Okay, so these are translating words into math operations, word problems for algebra. I think this is all cool, right? Addition, subtraction, multiplication,
Yeah.
division. I think this is all cool.
Hmm.
Yeah. You
Yeah.
can go through this later. I will share this deck with you. Yeah.
Huh.
What is a polynomial? All that you know. So I will not spend time. How to collect terms? So collect all the same power terms together. That's how we simplify algebraic expressions.
Yeah.
Yeah. When we deal with, we have done surds as well, right? We need to rationalize surds. So suppose you have a root a plus root b in the denominator, then we multiply both numerator and denominator by root a into root b.
Hmm.
Basically, what I'm saying is, uh, one second.
If I have root a in the denominator, I multiply by root a by root a. If I have root
Yeah,
a
like
plus b in the
this.
denominator, it will be root a minus root b is what I'll multiply it by. So it becomes
Correct.
a minus b. A square
Yeah,
minus b square.
just multiply by the complement.
Yeah.
So
Complement.
that's how we will simplify anything which has irrationals or surds
Hmm.
inside. We have done this part.
Yeah, yeah, yeah.
Yeah. Uh, what else do we have? Okay, this is simple here. We have the variable values. Okay, and we need to evaluate an expression. So that's simple. Just substitute. Correct.
Hmm.
So
Correct.
this is simple. Uh, how do we solve two equations with the same solution? Okay, suppose you're given these two equations. Now, can I say the second equation is just a multiple of the first?
Yeah.
Yeah. Likewise, if you look at these two equations, can I say they are multiples of each other?
Correct. Correct.
So when two equations are multiples of each other, there are infinite solutions. Just make a note of that.
Hmm.
Infinite solutions. And the reason why they're infinite solutions, because it's one and the same line. Two
Hmm.
equations are multiples, which means we're talking about same line.
Correct. It's one on top of the other, sort of
Yeah,
overlapping.
correct. So same line, which means suppose we are dealing with 3x minus y equal to 6.
Hmm.
Yeah. So x can take any value. Let x be 1. So we will have, say, y will become minus 3. If x is 2, then y will become 0 and so on and so forth. So I
Hmm.
can have infinite number of combinations of x and y.
Correct.
Yeah. So whenever two equations are multiples of each other, it has infinite solutions. That's one. Second is when the two lines are parallel to each other, they will have the same slope.
You will have no solution.
And they will have no intersection solution.
Correct.
No intersection. Correct?
Hmm.
Parallel lines. So that's the second case. And an example of that is ax plus by equal to c1 and ax plus by equal to c2.
Hmm.
Third case is where there's a solution, and this is called simultaneously solving the set of linear equations.
Hmm.
So equation 1, equation 2, and it leads to one solution.
Hmm.
Yeah, so this is simultaneous equations.
Correct. Okay.
Yeah, this is the third case. Now, coordinate geometry also will be doing simultaneously here.
Okay.
Yeah. Sorry, my PPT is gone. One second. Just a second. Let me just put it back up. Restart it. Sorry, I retrieved the file, but I've lost all the annotations.
Okay.
Yeah, so I'll just quickly write again. Okay, first case is infinitely many solutions. That's the case where we have, say, ax plus by plus equal to c, and then we have akx plus bky equal to ck. Basically, these are multiples of each other. So there are infinitely many solutions because this is how the graph will look like. Yeah. Second case is where parallel lines are there. And we have ax plus by equal to c1 and ax plus by equal to c2. These do not have any solution. And third case is where they are intersecting. Yeah. So ax plus by is equal to c, a1 and a2x plus b2 y equal to c2. So one solution because they are intersecting. Now, in terms of a bit of coordinate geometry intro here also, wherein suppose we have a line which is, so can I say when we talk about a line, it can be represented in various ways. The first way of representing a line is y equal to mx plus c.
Yep.
So that's called a slope intercept, right? Where this is the slope and this is the intercept. This is also the y-intercept, by the way.
Correct.
This comes when you put x equal to 0, so y equal to c. Yeah. So this is the slope-intercept format. That's one way of interpreting the line equation or writing it. This we will use when we know both the slope and the intercept.
Okay.
Yeah. The second way of getting a line equation is using this y minus y1 equal to m into x minus x1. This you will use when you know the slope and you know one point x1 comma y1 known.
Achha, when you know the slope and 1 point.
Yeah, and you know 1 point x1 y1, then you can find the line equation.
Okay.
Yeah. So for instance, we know the slope, we know what the slope is, and we know that the line passes through x1 comma y1. We don't know the intercept, but we know that slope is m and we know it passes through x1 y1. So then we will use this to find the line equation. Third is we get an equation of this format, ax plus by equal to c. Now the question is, if we have an equation of this format, what is the slope and what is the intercept? So what is the slope and what is the intercept?
Okay.
This is important because a lot of times directly the equation will be given to us. And then we will need to interpret what is the slope. So I will write this in the format of y equal to mx plus c. Okay, so I'll rewrite it. So can I write by is equal to minus ax plus c and y is equal to minus a by bx plus c by b. Clearly this, this becomes the slope and this becomes the intercept.
Okay.
Most important is this is the slope. Minus a by b. So if I'm given a line equation which is ax plus by equal to c, I can directly find the slope. Is equal to minus a by b. So just take the ratio of the coefficients and minus.
Okay.
So if I tell you 3x minus 4y equal to 5, what is the slope of this?
This is 3 by 4.
Yeah. This is 3 by 4. If I tell you 3y minus 4x equal to 5, what is the slope?
It's again 4 by 3.
4 by 3, you'll have to just rearrange. Yeah. So x coefficient is 4 and y is 3, minus 4 and 3. So negative of that is 4 by 3. Good. And if I tell you we have 3x is equal to 7y plus 5. Slope?
Minus 3 by 7. Oh, no, it's 3 by 7. Sorry.
3 by 7. Yeah,
Yeah.
you get this here. So you'll have minus 7y. So slope will be 3 by 7. Yeah. Okay, so this is important. Given the equation of the line, what is the slope directly? Looking at it without doing anything. So we don't have time to do all this on the GMAT. So whenever the equation is given directly, we can assume what the slope is or calculate what the slope is using this fact. Yeah.
Okay.
So that's one thing. The other thing is the concept of perpendicular lines. Yeah. So can I say this line?
M1, M2 is minus 1.
Yeah. So this slope, can I say, is minus a by b? So the perpendicular line, can I say its slope will be reciprocal and minus of that? So b by a. Basically, slope of any line and slope of its perpendicular, is minus 1. Yeah, so we've used that fact here. Yeah, so just a bit of detour on this. So various equations of the line here. And here we have solutions. When do we have infinitely many solutions is when the two equations are just multiples of each other. When we have parallel lines, there is no solution. When there are intersecting lines, we have one solution. The line can be of various formats: slope, intercept, A. B is you have slope and you have one point on the line. And C is you already have the generic equation from which we need to reverse engineer slope and intercept, which we have discussed. We have discussed perpendicular lines here. Yeah. So these are some of the basics on linear equations. Make sense? Now, just a bit on graphing. Sometimes it's important to graph in coordinate geometry also. So if I tell you the equation is 3x minus 4y equal to 5, how will I graph this?
You sort of put if x is 1, then what will y be?
Yeah, so put x equal to 0. So y will be what? In this case,
5 by
minus 5 by 4. Then put y equal to 0. X will be equal to 5 by 3. So can I write one point is 0 comma minus 5 by 4 and the other point is 5 by 3 comma 0. Yeah, and then we can plot it on the axis, right? So the first point, can I say, has negative y, so we'll plot here 0 minus 5 by 4, and this one, the first point. Second point is going to plot here 5 by 3 comma 0 as the second point, correct? And then the equation will obviously be this line. If you closely observe, what is the slope of this line, please? Positive. 3 by 4, correct? And hence it's upward sloping. Any line which is upward sloping has positive slope. Any line which is downward sloping will have negative slope.
Okay.
Yeah. So these are some basics on graphing. Why is this required? Because some questions might want you to, say, find the area between, say, two lines and an axis. So when you get an equation, suppose you get a problem of, okay, L1, L2 are the two lines. So what is the area of the triangle formed between L1, L2 and, say, the x-axis? So what is the area of this? So this is the application question.
Area is not in scope in portion, no?
Area is not in scope, but in coordinate geometry, you might still get some question on graphing, which might need a concept. So hence, to be on the safer side, it's easy. So for finding anything which relates to, say, the point of intersection, can I say there are 3 points of intersection here? So L1, L2 is going to intersect. How do we find the intersection point of L1, L2? Suppose I give you 3x minus 4y is equal to 5. That is L1. And I say 4x plus 3y is equal to 10. That is
I'll
L2.
solve both the equations and then find what x and y is. So that's the common point.
Correct. So we solve these simultaneously, right? And we get the intersection point, which is this. Correct? Similarly, when you put y equal to 0, in L1 you get this x coordinate. When you put y equal to 0 in L2, you will get the x coordinate.
Correct.
Because x-axis is y equal to 0 is the equation. Yep. So it's simple. So once we know the two line equations, we can anytime find the point of intersection. So far, so good?
Yep.
Okay. All right. Let's get to... Okay. So suppose we have to solve this equation. Now, can I say this is a linear equation with one variable? So this is simple, right? So take all the constants on one side and variables on the other side. So I will just write 5x minus 6 is equal to 12, 5x is equal to 18, and x is equal to 18 by 5.
Correct.
Yeah. So this is simple. So when you have an equation with one variable, just collect all these similar terms together. Constant on RHS, variables on LHS. And when we have two linear equations with two unknowns, yeah, again, we will solve them simultaneously. So suppose we have this as a set of two equations. So there are two approaches to solve this simultaneously. I will tell you both approaches. You see what is faster for you. So in one approach, you do a substitution method, which means you express one variable in terms of the other. So when I look at the second equation here, I can I say x is equal to y plus 2? It's easy. And that I will put in the first equation, which is 3 into x, which is y plus 2 plus 2y equal to 11. And then I can solve this. I can take all the common terms together. 5y is equal to 5. So y is equal to 1. This is one way of solving this is substitution, for which you need to express x in terms of y or y in terms of x.
Correct.
Yeah. X in terms of y or y in terms of x. That's the crux. Second is called as combination method. This is more powerful, in which you basically try to eliminate a variable on observation. How is that possible? When I look closely at this, I can very easily eliminate y by just writing that first equation as is and multiplying the second equation by 2. And just adding the 2. So 5x will be equal to 15, x will be equal to 3. Put it back in this, and y will be equal to 1 then. Yeah. Is that fine? Are you with me?
Oh, sorry, I was talking on mute. Yes, sir.
Okay.
Yeah.
Yeah. So two ways of solving: combination, which is elimination, basically eliminate a variable, or second is substitute and eliminate a variable. Yeah.
Okay.
So if it's easy to observe and combine, then we do method 2. Otherwise, we do method 1. Yeah. Okay. So we have discussed this. Okay, this is important: factoring and quadratic equations. Suppose we have equation of this format.
Okay.
So what do? We will collect all the common terms together. But the question is how? Okay, so for this, what we will do is we will write LHS. If you clearly observe, you can take x common. It's in cube there. So I can write this as x square minus 2x plus 1 and RHS as it is for now. Okay. And then we observe this is a square. Correct? So can I write x minus 1 square is equal to minus 5? We never do the mistake of just cancelling the terms just because they are common on both sides. In equations, we'll have to club them together, which means we'll have to bring this term on the LHS and it will look like this, equal to 0. Now we collect the common terms. X plus 5 is common. I mean, x plus 5 is collected because x minus 1 square is common. And that is equal to 0. So now this equation has two solutions, minus 5 and 1. Yeah. Just because there are common factors on both sides, it doesn't mean we will just cancel them out.
Because x can be 0. X can be the
Yeah,
same
x
thing.
can be 1. Then you can't cancel it out. Yeah. And that could be a solution of the equation.
Okay.
Yeah. Yeah. So this is the other thing, which is factoring. Okay. Suppose you have this as the equation. What do you think we will do here?
So first of all, if I take x minus 4 on the other side, it becomes 0. So x minus 3 and x square plus 5. So then the solution would be minus 5, 3.
0, 3.
0 भी हो सकता है, हाँ.
0, 3.
0, 3 and minus 5.
And this is unreal. I mean, imaginary. So that is not possible.
Acha.
X into x minus 3 into x square plus 5 will be 0. This will give you 0. This will give you 3. But this will give x square is equal to minus 5, which is not possible.
Okay.
Because that will give us imaginary numbers. That's not out. That's out of scope here.
Okay.
Make sense?
Yes.
So this is how we solve a complex equation involving one variable but having multiple powers. So we try to see if we can factorize in this format.
Okay.
If not, the other way of factorization is the product and the sum rule. For instance, when I look at this quadratic equation, yeah, x square plus 6x plus 5 is equal to 0. We will take the constant term where we say that is equivalent to product. And this, the coefficient of x is equivalent to sum. Okay. So this product can be written as 1 into 5. Because when I write product as 1 into 5, the factors 1 and 5, the sum is equal to 6. So can I write this as x plus 5 into x plus 1 is equal to 0? Which means the factors of this equation are x plus 5, x plus 1. But the roots of this equation are minus 5 and minus 1. Please note, when we factorize, we get factors. But we need to flip the signs of the factors to get the roots. Because when x plus 5 is 0, x will be minus 5. So you have to flip the sign. Flip the sign.
Okay.
So had the factor been x minus a, the root would have been a, right? Yeah, that is what it means.
Okay.
Which also means if I know the root of a polynomial, suppose I tell you fx is a polynomial. Okay. And I tell you a is a root. What does it mean? It means f of a will be equal to 0.
Okay. No,
Correct?
no. I mean, okay. No, I mean, it would mean that if I put A, if I substitute A, then I can solve the equation, no? Why you said 0?
Because if A is a root, then the polynomial is basically a function of x minus A into something, into
Okay.
some term. So if I put x equal to A here, I get 0, no?
Acha.
For instance, okay, take a step back. Suppose this same equation, x square is equal to x square plus 5x plus 6 equal to 0. We said we can factorize this
5 and 1. So
as
minus 5
what?
minus 1.
Sorry, it was this 6x plus 5. So 1 into 5 will give you 5, but the sum will give you 6. So factors were x plus 1, x plus 5. But roots were what? Roots were minus 1 and minus 5. Now, if I tell you put minus 1 inside this, it will fetch you 0.
Acha.
Because as soon as you put it here, one term will be 0. Or you put this here, that term will be 0. Or the polynomial sets to 0, essentially.
Okay. 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 Got it. Got it. Got it.
Got it?
Dozen roots.
So that's how it looks, yeah? So this is the relationship between root, factor, and polynomial. And how to look at a quadratic and try and factorize. So how do you solve a quadratic is we have looked at factorization, right? This is an example of factorization. What we looked at. Okay, one more example. Can you see what you can do here? Can you factorize this?
Just
3x square minus 3 is equal to 8x. Try this.
1 sec. This one. Acha. 3x square minus 3x. 3 is equal to 8x. Sorry.
So obviously bring this on the LHS.
Eight and 1 करना पड़ेगा. 9 and 1, sorry. See, x minus 9 plus 1.
Minus 9 plus 1. Okay. So here even x square has a coefficient, right?
Yeah, so you take
In
3
the
to
yeah, sorry.
So x is 3 or x is minus 1 by 3. Acha, you
So
did that.
is the product minus 9?
You take it as 9, no? And then I took it as minus 9 plus 1. So
Okay.
it adds up to minus 8.
So 3x
And
square
multiply
minus
minus 9
9x.
plus
Okay.
x.
Plus x minus 3 equal to 0. So 3x is common. X minus 3 plus 1, x minus 3. Okay. And obviously then we say x will be either 3 or minus 1 by 3. Right. So when we have a coefficient on x square, the product is the multiplication of the coefficients of x square and the constant term. If there's no coefficient on x square, which means x square coefficient is 1 rather, then we just take the constant term. Otherwise, we'll have to multiply. Yeah, makes sense?
Yeah.
Okay. All right. So this is about factorization. If we can't factorize, then we have to fall back on the old school quadratic formula. And the roots are given by minus minus b plus minus root of b square minus 4ac divided by 2a, where the equation is ax square plus bx plus c equal to 0.
Okay.
And the two roots are these. When will the roots be equal?
When will the roots be equal?
Hmm.
When will they be equal?
When there is no plus minus, right? They will be unequal if you have a plus minus here. If you make this term as 0, then both the roots will be minus b upon 2a, right? And that happens when the root term becomes 0. Then the two roots are equal. And the equation has only one root.
Okay.
Makes sense, right? So when b square minus 4ac is 0, this expressions, so when if b square minus 4ac is 0, then can I say this expression becomes minus b by 2a, one root only, correct? And if b square minus 4ac is less than 0, no root.
Imaginary.
Yeah, no real root. So as far as GMAT, no root. Yeah. Okay. All right. So these are basics of quadratics. Inequalities, important topic. These are the various inequalities. We know that already. Now, how to solve inequalities? Okay. Let's take example 1, this one. Always isolate x and the constants as always. So when we had a linear equation in one variable, we had a equal to sign. Now we have a greater than sign here. Yeah, so I'm going to solve example 1 here. So 3x minus 2 greater than 5. We collect all the constants. If you are moving around the constants, adding or subtracting, it doesn't change the sign of the inequality. Yeah. So, okay. Rules. I'm going to write them here. Rules. Adding, subtracting doesn't change inequality. However, also dividing, multiplying by positive doesn't change inequality. But when you multiply or divide by negative, inequality flips.
Correct.
For instance, here I can simply divide by 3 because 3 is a positive number. So I get x greater than 7 by 3. That's the solution for example 1. Yeah.
Correct.
Now, example 2 is this is the inequality. How do we solve that? So let's put it out here. Now, clearly the denominator has a minus 2, right? So now if we multiply both sides by minus 2, it will flip the inequality.
Okay.
We have multiplied both sides by minus 2. So inequality flips. So from less than it becomes greater than. And that's the third rule here which I've written. If you multiply or divide by negative, inequality flips in sign. Yeah. And now we can collect all the constant terms together. So fx greater than minus 5, can I write? And x greater than, now you divide by 5, that will not change the inequality. So x is greater than minus 1. Yeah. So this you will divide by 5 on both sides. That will not flip the inequality.
Okay.
Yeah.
Got it.
Okay. So that was example 2, where we were multiplying by a negative number or even dividing, whatever that is. Okay. The polynomial, any expression can be expressed as a function, a polynomial function. For instance, this x cube minus 5x square plus 2 can be written as f of x equal to. So then I'm creating basically a function of a variable where variable is x, but the function is f of x, also called as polynomial of x. Yeah. So f of x, and then you have another expression in 2. You have a z variable there. So then I write, okay, this is a new function. So I put g, and g of z is whatever is this expression, right? If I want to find the point of intersection of the two functions, I will directly put f of x is equal to f of g of z, point of intersection.
F of x is g of z. Right?
If you want to find point of intersection,
Acha, okay.
generally this is true when you have the same equation, for instance, or same variable rather. So you have f of x and you have g of x. And if you want to find the point of intersection, then you put f of x is equal to g of x, and you will find point of intersection.
Yeah.
Make sense?
I mean, I would just solve the equations, no, or same thing.
Basically, what we are doing is we are setting the y values equal, because I can also write y is equal to f of x, and I can write y is equal to g of x. Basically, when I'm finding the point of intersection, I'm equating these two. So I'm making the y variable equal, or the y value equal. And then I'm equating f of x and g of x to find the point of intersection. And then whatever x I get, x comma y will be my point of intersection. And they could be multiple also, depending on the type of whether it's quadratic or cubic or whatever it is. Yeah.
Okay.
And then we can obviously find the values of these functions. So this is point of intersection. To find values of function, we will just substitute the value. For instance, if I want to find f of 0, I will put x equal to 0, right? Or if I want to find g of 1, I will put z is equal to 1 in the above expression here. So those will fetch me the values of the functions. A lot of time we deal with composite functions also, which means they will write f of g or g of f. F of g is nothing, f of g of x. And g of f is g of f of x. The difference is that here you put g of x inside f function, and here you're putting f of x inside g function.
Okay.
Yeah. Make sense?
Yeah, I think once we do a few sums, it'll.
So given these two, okay, 1 and 2, what do you think is f of g?
Where is it written? F and G? Upper.
ये f है ना? This is f and this is g.
Okay. So function of g. So I need to take g as a base. So 2z plus y upon root z plus 1. And in that I will have to submit. I mean, assuming that both you're putting as x only, no? Then I'll put instead of z, I will substitute x cube minus 5x square plus 2. So it'll be 2x cube plus 5x square plus 2 plus 7 upon root of this thing. So basically, I'm substituting the value of f of x into z of the second part. And if it's ulta, then I will substitute g of x in the first equation.
Yeah. It looks like this, right? Correct? So this is how f of g looks like. So g is nothing but this. You put that here. And then instead of x, we write x is 2x plus 7 divided by root of z plus 1. So wherever there's x, replace by that expression. Yeah. So that is f of g. Is f of g equal to g of x?
Oh, no, because I'll have to in the second equation I'll have to submit kya? Substitute the first part. So
Yeah.
2 of x cube minus 5x square plus 2 plus 7 upon root of the same thing. So
Yeah. So what is g of f? G of f will be g of x cube minus 5x square plus 2, right? And that will be nothing but 2z plus 7, right? So instead of z, I will write 2x cube minus 5x square plus 2 plus 7, and the whole divided by root of z plus 1. And z plus 1 is nothing but this bracket plus 1.
Yep.
Yeah.
Okay.
All right. You're able to hear me, right?
Yeah, I can hear you.
Okay. Next is the domain and range of any function. So this algebra also covers functions, by the way.
Okay.
We'll just put it out in our plan. This is also covering functions. Okay. Yeah. All right. What is domain and what is range? The set of all allowed inputs for a function is called as function's domain. And the range is the set of outputs. Input is domain and output is range. What do I mean by that? It means your x is the domain and y is the range. For instance, if I write y is equal to 1 divided by x minus 4. So what is the domain?
Domain is the input
And what is the range?
what is the input in this?
Yeah. What are the values of x? Possible values of x. That is the domain, right?
Acha. Okay, so x
So,
cannot be 4.
So all x except x equal to 4, correct? Which also means x cannot be equal to 4. Otherwise, all x. All x, but x not equal to 4. And what is the range?
I don't know, minus infinity to 3 and 5 to infinity.
Okay. And is 0 possible?
0 minus, yeah, why not?
So when is y is equal to 0?
When is y equal to 0? When x is yeah, it's not possible, no?
So when x is 4, it becomes infinity y. When x is 0, what happens?
When x is 0, it's minus 1 by 4.
Okay, let's try to see how this will look like, okay? For which I need x and y's. So all I'm saying is, whenever in doubt, just put out some values, okay? So when x is 0, what is y? Minus 1 by 4.
Minus 1 by 4, huh?
So it sort of gives you the intercept. Which means when x is 0, which means y-axis we're talking about. So this function starts from this minus 1 by 4. From here it starts. Okay. When x is 0. What about x equal to 4? What happens?
Then that's infinity.
Oh goodness, it becomes infinity. So as soon as it becomes 4, it becomes infinity. So suppose this is 4 comma 0. here. So when
Mhm.
x is equal to 4, y value is undefined.
Mm.
It can be anything on top. It becomes extremely steep, right?
Mm.
So can I write like this, something of this sort? It becomes like an asymptote here.
Mm-hmm.
All right. And what about when x is negative? We've considered only 0 and positive.
Mm.
What about x equal to 10?
If x is 10, 1 by 6.
1 by 6. And what if x is 100?
1 by 96.
1 by 96. So what's
Mm.
happening to, okay, and when x is 1000?
1 by 996.
So what do you think is the relationship between x and y in the second part here?
As x increases, y decreases.
Yes. As
Correct.
x increases, y decreases.
Mm.
So how will we plot that? So somewhere what we're saying is, as x increases, y will drop.
Mm.
So something of this sort, is it?
Okay, yeah.
Hmm. Okay. All right. Okay. And what about negative values of x?
Negative values of x, if I take -1, so then -1 -4 is -5, so -1 by 5.
Hmm. Minus 1 by 5.
Now,
So
that's
when,
also going to go on decreasing only, no?
yeah, when x is -1, for instance, y is minus 1 by 5.
Uh,
And when it's -10, it is -1 by 14.
mm,
Correct?
mm.
So it keeps on decreasing lesser. Okay, so when x goes down,
Y also goes
actually
down.
y is not going down, y is increasing. It becomes
अच्छा
less
वो
negative, less
हाँ
negative.
हाँ ओके ओके ओके
है ना? यहाँ पे
-16
यहाँ पे it was different. When x was going up, y was reducing.
ओके
And in this negative zone,
उल्टा हो रहा है हाँ
ulta हो रहा है ना?
हाँ
Yeah, so this is the example of a hyperbole equation. Yeah. I'm just giving an example of how will understand what is domain and range.
so here what's the range, is it not -infinity to 3 and 5 to infinity?
No, so if you look at y value,
हाँ
can I say it extends till infinity? So no problem there.
हाँ
But we were also saying it could be minus infinity,
hmm
right? Initially.
correct
Yeah. And your y is, can I say it will go towards 0 when x becomes too negative, right? But my question is, when will y become too much negative?
when will y become too negative?
Yeah. Like is it possible for
When
y
x
to be
is
equal to
3.
-10?
No, I mean y will be negative when x is 3 or less than 3, no? Or basically less than 4.
Huh. No, my question is, can
Huh.
you tell me when y will become equal to 10 and -10?
When
I'm
y
writing
is
it here.
10.
Huh. Yeah. When will y become 10 or -10? Look at this equation and tell me.
So x should be. I mean, if I solve it,
No need to solve
how will I know
because
by
you
looking
want,
at
okay. Okay. So you want y as 10, right?
it?
Which means what if x is 4.1?
4.1. Acha.
So when x
Point
is
one.
4.1, the difference between 4.1 and 4 becomes 0.1, and 1 divided by 0.1 is 10.
Correct.
by observation. And
Ah,
when will y be equal to minus 10?
3.9.
Yes.
Okay.
So when will y be equal to 100 or minus 100? Just shift the decimal one more.
Hmm.
4.01. And in
Hmm.
this case, 3.99.
Hmm. Hmm.
Yes or no?
Okay. I'm still trying to understand what sort of questions will come on this and what is the range here.
Exactly. That's what I'm coming at.
Okay,
As soon
okay.
as you just change the domain a bit, as you can
Uh-huh.
see by one decimal, the
Uh,
range is increasing here. So the range is minus infinity to infinity.
and it shouldn't be 4, no?
And the domain shouldn't be 4.
Acha, okay. Because I was saying 3, you're trying to tell me that it could also be in decimals, so I cannot say it's still 3. That's what you're trying to tell me.
Yeah, that's what I'm
हाँ,
trying to tell you. Yeah.
ठीक है, okay, okay, okay.
So y can be any value from negative minus infinity to infinity,
Mm,
but x value cannot be 4. Otherwise, it can be anything.
okay,
So
makes
range is
sense.
everything, domain is everything, but domain excludes 4.
Hmm,
Range is value of y, domain is value of x. That's all.
makes sense. Okay.
Okay. So
Just
we'll solve a few problems later of domain and range,
okay.
but for now this is good. I hope you've understood. We've taken a slightly complex reciprocal example, but I hope you're able to understand.
Yeah,
Yeah.
I understood what you're telling me. Maybe after solving sums, it should be better.
Yes. Okay. I'll give you one more, a simpler one. Okay. Y is equal to x plus 4. What is range and what is domain? What is domain and what is range?
Okay. It could be anything, no?
Exactly.
There's
So
no
domain, which
denominator.
is value of x, can be anything, all x.
Ah,
And if all x, that means range could be
minus
anything.
infinity to infinity is the range. Ah,
Yeah. So all y, which means minus infinity to plus infinity, everything on
okay.
both sides. Yeah.
Hmm.
So simple linear equations will have simple ranges and domains. Yeah.
Hmm.
Things become complicated when you have reciprocals inside.
Okay.
Yeah. So for instance, if I give you y is equal to x plus, we did that example, right? Y is equal to
One of
x
the
1 upon x minus 4. So your the domain is all x,
minus except for.
but or except sorry, but x not equal to 4. Correct.
Hmm.
And range is all minus infinity to plus. Yeah. What
Okay.
about this?
X plus 4 upon x minus 4. Same
Mm,
thing, no? X cannot be equal to all x but not equal to 4.
yeah. So domain is what? All
All
x.
x but no, it's not equal to 4.
Yeah.
And range, same answer, no? Minus infinity to plus.
Range could be okay. All.
Mm.
Okay. All right. This is good enough for now. Graphing we've already completed. I've
Mm.
told you. We know the quadrants, right? 1, 2, 3, 4.
Yeah.
One has both plus plus x and y. This is always x, then followed by y. For
Mm.
the second one, it will be minus x. For the third quadrant, minus minus. Fourth quadrant, plus minus.
Mm.
What should be the equation of a graph never to pass through third quadrant? Can you tell me?
Okay. Uh, then x and y both can't be negative.
Line never passes quadrant 3. What does it mean? It means it will look like this.
Mm.
And can I say slope is negative? But both intercepts are positive.
Mm.
This is positive, this is positive. But it never passes through Q3, correct?
Yeah, I mean, unless it passes through the origin, then it's not positive, it's 0.
Yeah,
Yeah.
exactly. Okay.
So it cannot be
So,
negative, is basically what you're saying.
yeah.
Hmm.
Okay. We know all this. Y-intercept, X-intercept, all this is fine. We have done. Okay, slope. Okay, if suppose these 3 points were given to us
Hmm.
and we are asked what is the slope. Slope is nothing but delta y by delta x. Change in y coordinate divided by change in x coordinate. So here the 2 points say are -2, 2
Hmm.
and 0, 1. So
Hmm.
what is delta y in this case? Change in y is delta y. So 2 minus 1. And what is change in x? -2, 0.
Hmm.
So slope is minus half.
ठीक है y2 minus y1 x2 minus x1.
Hmm. So slope is minus half. So what is the equation of the line?
So c is 1. So y is equal to -1 by 2x plus 1.
So c is 1, right? Y
Yeah.
intercept. So I can directly write y is equal to mx plus c.
Correct.
And I can write y is equal to minus half x plus 1. This is one way of doing it. The other way of doing it is use the slope and use one of the points.
Hmm.
So that means y minus, so if I put 0, 1, and if I put m is equal to minus half. So can I write y minus 1 is equal to minus half into x minus 0?
Hmm.
And that will also fetch me the same thing only.
Hmm.
But both are equivalent.
Hmm.
Same. Just different methods. Yeah.
Okay.
If the points are collinear, that means they will lie on the same line. Like these 3 points are collinear.
Hmm.
They lie on the same line, and the difference and the slopes are the same between any 2 points.
Hmm.
So slope between say part 1 and slope of part 2 are the same because it's the same linear equation.
Hmm.
Okay, so that means collinearity. Collinear. Okay.
Hmm.
So I think this is good for now. Let's see if there's anything more to do here. No, we can jump into questions.
Yeah.
Yeah. Okay, there are many questions here. So we'll try to do a few today.
Hmm.
Then I'll give you the rest for homework and then we can keep
Okay.
solving.
The number of employees at a certain company increased by 1 by 4.
Yeah.
Mm-hmm. 120.
120?
120.
Perfect. 120. Okay. So increase by a factor of 1 by 4 means what? It becomes 5 by 4, right?
Hmm.
Hmm. Decrease by a factor of 1 by 3 is 2 by 3. Is this how we did it?
Yeah, I mean, I I took that at the start they were x, then it increased by 1 by 4, correct? So I did x plus x by 4, which is basically 5 by 4. And then I did 5 by 4 x minus 1/3 of 5 by 4.
Yeah. So
That's it.
2000 to 2003, it increased by, or it increased by a factor of 1 by 4, right? So can I multiply by 5 by 4?
Hmm.
So x becomes 5 by 4x at 2003. And then it decreased by 1/3. So it becomes 2/3.
Yeah.
And if there are 100 employees in at this, so how many employees were there? So can I say x into 5 by 4 into 2 by 3 is equal to 100? Is this what you did?
Hmm.
Okay. So x becomes 120. All right.
Hmm.
Yeah.
Correct. Okay.
Good. Okay.
Following integers must be true. So following statements must be true about
This is
the
actually stats, but we can still solve it. It's not difficult.
of the AM and median of 5 consecutive integers. Okay.
Average and median of 5 consecutive integers. Best is to just take some 5 consecutive integers. Just take 1, 2, 3, 4, 5
Hmm.
and see what is true and what is not true. So what is the average? 3.
1 and 2 is true. The
Median
median
is also.
equals so 1, 2, and 3 all are true.
Hmm.
E is the answer.
Yeah. Okay. Next one.
Collection of 16 coins with face value of either 10 or 25. Let's put it 2.35. So y is 5. What do we need to know? How many coins have face value of 25? 5, no? 5, B.
5.
Huh.
Hmm.
B.
B, right?
Correct.
So we have 10 cents and 25 cents. I put this as X and Y. We've been given total is 16, right? So always total column towards the end. So this is total is 16. So one equation is X plus Y is equal to 16. And the other is the value equation. So this is number, the other is value. So 10x 25y total is 235 in cents. So 10x plus 25y equals to 235. To solve this, I multiply this equation by 10. So 10x plus 10y is equal to 160 because any which ways we need y.
Correct. Okay.
And 15y is equal to 75y is equal to 5. Is that how you did?
Yes.
Okay. All right. Next.
And choose one of the two methods, either annual salary with no commission. So, almost. C.
C, right? 125.
Yeah, yeah.
Okay. So I put F. I put variable, fixed variable. When fixed is 35, variable is nothing. Also, I'm not putting the zeros here. And when the fixed is 10, it is 0.2 into sales. Now they're asking when will the totals be equal? So 35 and 10 plus 0.2 S. When are these two equal? When 25 is equal to 0.2 S. So S is equal to 125. And I add those three zeros. Yeah. Okay.
Okay.
Yeah. Next. Which of the following have the greatest value?
How do you solve something like this?
Take some values. Best is take some values.
Should be E, because I'm multiplying it by the greatest number.
Take
No?
values. That is the best.
Acha. So 3, 2, 1.
But you also have to see the combination of the other two. So X, Y, Z. Suppose I take simple 2, 3, 4. So what is the first one? 4 into 3. Second one is 4 into 4. Third one is 2 into 7. Fourth one is 3 into 6.
So it's E only.
And Z is 4 into 5. Yeah. Your hunch was right. Yes. And
Yeah.
here we are not, luckily for us, the values which we took, no, none of the two answers are matching here. So it works. Fine.
Yeah, yeah.
Yeah. So either you use your logic, but better is to back the logic with some example. Yeah. So yes, it made logical sense that you multiply the largest number. If it's out, it's better. And instead of y plus 1, let's do x plus y. That is even better. But better to take some numbers and cross validate. Yeah.
Okay.
Okay. Fantastic. They have also used some algebra to do this. I will not suggest this. Just use some numbers and keep it simple. Okay. Next question.
Twenty.
20. Okay. B, 20. Yeah. Good, right? No need of explaining this.
No, fine.
Okay. Let's go on. Yeah. Next one.
What percentage of x? So 3x by 50.
Is what percentage of x?
12 by x, so 100. 6%, no?
6%.
Ah.
Okay. Yeah, A. Simple, right?
Simple.
Okay, next one.
Identical hollow binders. Each of you. Which one will find was 40? How much? 40. 4 is 60. 6 is 36. 560. C.
C, 560, right?
Hmm.
Okay, so P and O numbers are 5 and 6. Prices are, can I say X and 2X? But on 2X, there is a discount of 25%. So I need to multiply by 0.75.
Hmm.
And now they're saying hollow pine door is 40. So this is 40. So this becomes, can I say 1.5x? So this becomes 60. And now the total value will be 5 into 40 and 6 into 60. So that's your 560. Okay. Okay.
If k square is equal to m square. E, no?
Which one?
E.
E.
Yeah.
Sure.
Yeah.
Mhm. Okay.
E
To
only, no?
solve this algebraically, how will you solve it?
I mean, logically it's E. How is it? See, if I take a root on both sides, it will give me k is equal to m, but it's also possible that one of them is negative.
Plus minus, yeah.
So that's why I cannot say it's A. And
Mhm.
even BCD logically cannot be.
Yeah.
So it should be E only. So, I mean, whenever you take a root, you need to put modulus.
Mm.
The mods will always be the same, even though the numbers are not.
Mm.
Correct, no?
Yeah. So, okay. Why not C and why E, according to you?
Because the mod is not on the left, no?
Mod is not on the left. Okay.
Yeah, so what if it's minus k? What if k has a negative? Then it won't be equal.
Can we take a numeric example value?
So say 2 square is equal to minus 2 square.
So
So
2
then,
square is equal to 2 square or 2 square is equal to minus 2 square.
so if k is minus 2, so it will be minus 2 is equal to mod of 2, which is not the same.
Hmm.
No. I'm saying if k is minus 2 and m is 2, so then c won't be true.
So C is only true for positive values of K.
Yeah.
But as soon as I write minus 2 and 2 or minus 2 and minus 2, this won't work.
Correct.
Yeah. So C fails here. But E is everywhere it's true. Mod of equal to mod. So mod of minus 2 will become 2. So 2 will be equal to 2. Even if you put a minus 2 inside or a 2. Yeah. Okay. The reason I'm saying this is, see, this is a simpler problem. So direct observation E is easy to figure out. But in a slightly more complex situation, we should fall back on some numerical values and do some scenario analysis if required. Yeah. Otherwise, it's not needed if it's simple. They have taken scenarios, for instance, here.
Okay.
Okay. Now this is easy. This should be done in a few seconds.
Okay. N is 4.
N is
4.
4 or minus 4?
4. Oh, minus 4. Sorry.
Minus 4. Yeah. Okay. Next one.
Okay. $16. DD.
16.
Mm-hmm.
Okay. Yeah. It's 16. That's correct. No explanation, no needed here.
No.
Okay. All right.
Total of S oranges that will packed in boxes that will hold R oranges each. S minus NR.
Yes.
S minus NR, no? Number of total oranges that I fill is number of boxes into oranges per box, and I subtracted by the total oranges. So A should be the answer.
Okay. E is the answer.
What?
Yeah.
I need to hold R oranges in each box. No. One box has R oranges and I have N boxes. So total oranges that I've
No,
boxed are
you have
NR.
first. Okay, let's go on the first line. So total of S oranges are packaged in boxes such that they will hold R oranges each. So can I say each box is R and number of boxes will be S by R?
Oh, okay. Okay. S by R is number of boxes. And then I'm saying number of boxes that remain. Okay, understood. S by minus N. Understood.
Got it, right?
Yeah, I got it.
Seems slightly weird, but it's actually simple. So as always, I always see, if you see my method, I've always been drawing something. Like here, I put the variables, then I put, say, number, price, total. Everywhere I'm doing this. So that brings a bit of homogeneity in terms of my solving. So slightly more complex situations are easier to handle. For instance, here also I took the same approach. Okay. This one, I think we did.
Yeah, we did then.
I wrote capacity of box. Then I wrote number of boxes. Then I wrote total. So capacity of is R. It's given. Total is given as S. So S by R are the number of boxes. But they are saying N are filled. So filled, not filled, correct? So N are filled. So not filled are clearly S by R minus N. Yeah.
Okay.
Makes sense, right?
Yeah.
So this works. Variable capacity, variable and total, which is capacity into number or volume of each into number, whatever you want to put it as. Yeah, capacity of each box and number of boxes and the total oranges. Yeah, so becomes easier to visualize.
Yeah.
Less errors.
Okay.
Okay. So this is my standard approach framework in algebra. I first identify the variables, and variables need not be xy. Variables are the entities which are unknown. For instance, here we had total, we had number of boxes, and we had, okay, in each box how many. So those are my variables which I'm talking about. So those I'll put columns, and then each of the scenarios I'll start putting in rows. So here we have only one scenario. Then we have been given n are completely filled out of those boxes. Filled and not filled. I could also written this as, okay, this is total. So not filled are S by R minus N. Yeah.
Okay.
All right. Next. This one.
Maybe say about 0, what is true? So 2 is true and it's only 2, no?
Only two. Could have been done logically also, but best is to take values
Yeah.
for no ambiguity. See, when you do it directly, without values, there is a scope that there could be some error in logic. Since, see, there's time pressure on the exam. So in the quest for solving it fast, it's possible you make errors. So best is to use some values. So I take 1, 2, 3 easy numbers to deal with. And clearly 1 is not true because 2 cannot be greater than 5. Second is C minus A. Obviously is greater than B minus A because C is greater than B also. So that's logic also. And 3 is also actually logic, but here it's simple. So 3, C by A is 3. It cannot be less than 2. And also logically also that is true, right? C by A divided by B by A. C by A cannot be less than B by A.
Correct.
Yeah. In this particular case. Correct?
Correct.
Yeah. So it's only 2. Best take values and validate quickly.
Right. I did the same thing.
Yeah, good. All right.
Coming plans to make any product next year. 97 goals.
Sorry, I forgot the timer.
Okay. Hmm. Very hot. Very hot. It's A. I initially got the wrong answer, so I had to resolve it. It's A, no?
Yeah, it's A.
Hmm.
Hmm. So, okay. So, selling price 2, variable cost is 40% of selling price, so 0.8,
Hmm.
and fixed cost is 5040. Now, obviously, so this is per unit, right?
Hmm.
For X units, can I write 2X 0.8X 5040? Now, this is costs and this is revenue. So
Hmm.
2X is equal to 0.8X. So they are asking break even. So 1.2 is 5040, X is 5040 divided by 1.2. I don't even need to calculate. The answer is A. There's only one answer. See, because 1.2 into 4 will give you 4.8.
Hmm.
There's only one answer with 4 in the thousands. So this is the answer.
Hmm. Okay.
Yeah. So sometimes no need to even solve if the options are favorable.
Hmm.
In the sense, okay, there's only one option with say 4,000. So yes, answer is A.
Hmm.
Yeah.
Okay.
Yeah.
Makes sense. Okay.
Makes sense. So now we'll stop for today.
Yeah.
I shall give you this pack to solve. You
Hmm.
can solve, say, 30, 40 questions from this pack. Let
Oh,
me
there
know
are
when
30,
it's.
40 more, is it?
Yeah, yeah, there are many more. In fact, there
Okay.
are 100 odd questions here in this pack.
Wow. Okay.
Yeah, so, but you can solve a few of those. And in the next session, we can discuss. I think you have some doubts from the previous
Yeah.
PDFs which I sent you, right?
Yes.
Also. So can you collect them together
Hmm.
and send me as one doc? Is that possible or too much of an ask?
No, I don't mind sending, but I thought it'll be better if I tell you exactly which one it is, no? Because I've marked and kept. That is, for example, ratios and proportion question 79 is where I'm not clear. So I've marked it and kept, and then I can discuss with you exactly what the issue was.
That also works.
Yeah.
So you want to do it? I can again log in back later if that is okay.
Okay.
If you are okay.
Either that or we can maybe on the next session extend a bit
Next
and
session, yeah, that is also fine. If you have time today, we can log in back because I need to go right now.
okay.
But we can log in back or we can do it tomorrow.
Okay. ठीक है.
So we will first do all the doubts of the previous PDFs and this one,
Hmm.
and then we can move ahead. We can
ठीक
do
है
that.
चलेगा. चलेगा
चलेगा ना?
चलेगा. Today I'll let you know. Otherwise we can do tomorrow.
चलेगा चलेगा. No worries. No
ठीक है.
pressure.
Tomorrow, what time are you available? Can we set at around? Can we target 9 o'clock?
We can.
You can.
Yeah.
Okay. I'll try to come earlier if you are also available. But
Hmm.
if 8 is possible, otherwise we can keep 9. We'll we'll
Yeah,
coordinate on the
before 8:30 is difficult because that's
yeah.
my dinner time and time to
Oh,
spend with kids. But I can from
okay.
8:30 onwards, 9 onwards, I'm free.
Okay, no problem, sir. We'll coordinate on the group.
Yeah, yeah, yeah. Cool, cool.
Okay. Chalo. Thank
Fantastic.
you.
Let me send this back to you. Yeah.
Yeah. Thank you.
Cool. Thank you. Take care.
You too. Bye.